Big data is a term for complex datasets that traditional data processing applications are inadequate and incompatible to deal with them. Taking medical field as an example, large integration of data such as doctors' written notes, prescription, and medical imaging in medical journals needs more advanced technology to handle all those data in one server. Therefore, new medical big data analysis tools are introduced to cope with the needs. Here are some examples: 百度千禧, electronic health records, and telemedicine. There are three major advantages to the healthcare providers. Firstly, the medical big data analysis can provide better clinical design and match of treatment to individual patients by using it to discover trends and patterns within the data. It can improve the medical service.
Secondly, the big data analysis can link out the health system with different disciplines, for example, in cancer treatment. Thirdly, we can get an overview of a management of a particular disease, such as diabetes, from prevention to end-of-life service, so that we can improve the management. The Watson Analytics is a famous example of big data analysis, which can efficiently interpret patterns and meaning of our data by automatically generating predictive analytics for interpretation. We do not need to equip with sophisticated skills of statistics because the tools are able to spot a trend or visualize report data in the dashboard. There are some extraordinary features that can be illustrated by Watson Analytics, which will be discussed later.
The second part is to illustrate the major functions of IBM Watson Analysis. We have concluded 6 functions in total. The first function is calculating the data quality score. This is shown by IBM in percentage spontaneously. These scores indicate how suitable your data is for making predictions. The higher the score, the lower the number of outlier or missing values. This can give a brief concept of your data and compare with other datasets. As IBM Watson is originally used for business use, to illustrate the key functions of the IBM Watson, a set of business data named Analyst Test Market Campaign is used. The second major function is Ask a Question. Asking the question just like setting the title of the graph. The tips of asking the question is to keep the question short, descriptive, and unique. For example, I would like to investigate the association between the sales and the age of store. I can simply type in what is the relationship between sales and the age of store. Then IBM will automatically suggest optimal visualization to me. This can shorten the time required to extract the key points of the data. The third characteristic is starting point. If we don't have any idea on the large data set, the IBM will suggest us some starting points for illustrating the most significant relationship between different factors. This function is user-friendly as sometimes it is extremely hard to interpret the data when we just look at the 1000 number in the Excel file. In this case, IBM suggests 6 visualizations for 6 combinations of the relationship between factors. We will use one of the relationships as the illustration for the following function.
This software also has an useful tool that's called Discoveries, which suggests further investigation on the aspects we would like to focus on. For example, if we want to look further on the relationship between age of store and sales, we can select this graph. It shows a result in a combination graph. To change the graphic setting, we can simply click on the axis, like whether showing the results in sum or average. For further change in the graph, you can select Format at the left side column. If we would like to examine additional factors, we can simply drag the factors from the lower parts of the page onto the designed cluster. For example, bars, color, length, and multiplier. IBM will automatically build a suitable visualization for you. To remove the extra factor, we can click on the small arrow and click Remove to change the factor age of store to market size on the x-axis. Just change the factor by clicking the option Market Size. In IBM, another useful feature is that there are lots of visualizations that can be chosen to present. Different visualizations can serve different purposes and highlight different key points. IBM will also suggest the recommend visualizations for our focusing areas. For example, heat maps, packed bubble, tree map, and world cloud in this case. These visualizations are the most readable presentation when investigating these factors.
There are mainly three limitations of the IBM Watson. First, there is limited storage space. Only 1 MB of data storage can be used in a free trial edition. This will limit the scale of big data analysis. For the large-scale big data analysis, IBM Watson Plus or Professional may need to be used. Second, IBM can only give the insights of the decision-making and analysis of data, but not a direct explanation of the reasons behind the phenomenon. Further supporting evidence is needed to be found manually, which will be explained later. Third, IBM is only limited to analyze one set of data. Grouping two Excel files in the same file together is impossible.
Other than commercial use, the software can also handle big data in respect of medical fields. Take the Wisconsin breast cancer database as an example. 699 samples of cancer tissue extracted from fine needle aspiration was examined in 9 dimensions factor as shown. Each component is graded from 1 to 10, with value 1 corresponding to a normal state and 10 to a most abnormal state. In order to examine the relationship between different attributions and the trend of malignancy, traditionally, we could conduct a number of statistical tests. Yet, the process is time-consuming, high manpower demanding, and high risk of error due to multiple steps. If we use the IBM software, we can obtain a more efficient and user-friendly data analysis.
Using decision tree, the system will automatically analyze the strongest predictor among the attributes and generate a diagram with it. In this case, the most reliable attribute is the uniformity of cell shape, which has a predictive strength of 92.3%. Now look at its decision tree. We can see how different score of uniformity is related to malignancy of tumor. It is found that the score above 6 is very likely to be malignant tumor. However, the percentage is still not 100%. So the system is so smart to find another complementary attribute, the mitosis. Looking at the decision rule, it is found that if the uniformity of cell shape is about 6, while the mitosis score is about 1, then it could be 100% confirmed that the tumor is malignant. Now we can define threshold to confirm whether a cell is malignant or not. Immediate treatment are required for patients diagnosed with this range.
However, from the tree, if the uniformity score is not above 6, we are not confident enough to determine malignancy. In this case, we can use spiral prediction analysis tool to screen out the malignant cases based on other attributes. From the spiral diagram, it is found that spontaneous consideration of both blend chromatin and single epithelial cell size serves as the strongest predictor for this class, which has a predictive strength of 94%. From the displayed bars of trend, when a single epithelial cell score is equal or above 5, and the blend chromatin falls within the range 2 to 3, all the samples are malignant. Therefore, for samples that fall outside the confidence range in step 1, their malignancy can be confirmed by using spiral model.